Okay, g'day everyone. Welcome back to the channel. A little bit more work on state matrices and transition matrices. So, similar as last time, we're dealing with happy and sad people, but this time there is also people who are neither happy or sad. So, we've got happy people given by H, neither happy nor sad, can't make up their mind, or they're just having a day. There. So, if you love being put into boxes, these people obviously would have loved it. They have three emotions, and that's all. That's plenty. And how they feel can change from day to day. So it's given by our big transition matrix just there. In the matrix, the columns define the situation today and the rows situation tomorrow. Okay, so that's consistent. So I can go today, tomorrow. Okay. On a given day, 2,000 people, 1,200 are happy, 600 are neither, and 200 are sad. We need to give a matrix that sets that out. So part A is 1,200 are happy, 600 and 200. Now remember, I haven't just written them down because that's the order that they're given to us in the question. I've written them down in that order because that's the order they're given to us in the transition matrix. So HNS, row 1, 2, and 3, HNS, column 1, 2, and 3. Okay. So that'll be called matrix S, and we've got happy, neither, sad. The next day, how many people do we expect to be happy? Okay, so it's not asking us to write it out. If we had to write it out, I've done it a few times. Look at the previous video if you want to see the full version. The next day we can find by having S0 equals our, I'll put this single matrix in, the rest I'm just going to abbreviate. So that's S0, and every subsequent one can be found by multiplying T by Sn. Okay, so we're trying to find S1. So to find that, we need S0, plug S0 in here, and that will give us S0 plus 1. So S1 will equal, I've done this over here already. So I've got my transition matrix already set up. Hopefully it's all accurate, I'm pretty sure it is. Our state matrix here, and all we need to do now is T times S, and that is how many people. So what do we got? The next day, how many people do we expect to be happy? So be careful with your answer. So we've got that many, 440 and 290. Now the question asks us how many people are expected to be happy. So we need to tell them, not just state it in the matrix and even label it onto it. Bring it out of the matrix and state that 1,270 people are expected to be happy. Okay, tick for B. Part C, after 5 days, how many people do we expect to be happy? Let's find this using the rule. So our rule is Sn equals T, transition matrix to the power of n, times SO. And we're going to make T to the power of 5. Okay, 5 there. Times that by SO, which I've already plugged in. If you're asked to write it out, you should. If you think it's necessary for any question on a stack or test, you should be putting in the T transition in there and the state matrix there, the initial state matrix. I'm not, because I don't want this video to go for 25 minutes, unless you like listening to my voice, of course. You can make it go for as long as you want. So n to the power of 5 times S. There is the 5th day. Back here, and we are 1,310, rounding to the nearest person for this. 430, okay. The 8 rounds the 9 up, which in turn rounds the 2 up. And then 260. So C, after 5 days, how many people do you expect to be happy? Again, it's asking for happiness. So H, N, S. So 1,310 people are expected. Oh, where's my expected to be happy? Okay, so we're getting better or worse. We're getting slightly better from our initial 1,200. We're up to 1,300. Last bit. In the long term, how many of the 2,000 people do we expect to be happy? So let's just slide down a little bit. Okay, so D. In the long term, let's choose a high N value. So let's choose N equals 60, N equals 61. So we've got the consecutive values for N to find out where the steady state is. Okay, so T to the power of 60 times S, capital S for me, and T to the power of 61 times S. Okay, have we hit a steady state? Looks like it. So 1311, that'll round that to a 2, same there. 429, 429, that'll be rounded to 429, and then 259 and 259. Yeah, so we're all okay. So in the long term, how many people do we expect to be happy? If you need to answer specifically this question, we can put out our steady state matrix here, but the question is actually not asking for us to do that, so it's superfluous to what it needs. Let's just get rid of that. My mouse is acting up here. Okay. So 1312 rounded, 429 and 259. Now I can make a rough approximation that all still adds up to 2,000 because 9 and 9 is 18 and 2 plus that is 20, so that gives me a 0 on the end. So I'm happy enough to, for this example, go with that. So long term, in the long term, 1,312 people are expected to be happy and no more. So whatever happens, it would just get closer and closer to that value. And that's part B. So hopefully that was helpful. Give it a like, thumbs up, just email it to people, print it onto DVDs, play it at family get-togethers. I think all of that's a fantastic idea. Have a great night, guys. Obviously, I'm tired and I'm going to do dinner. See ya.